start recording again. So now we're gonna go to 11.4, where they say calculate the maximum kinetic energy of an ejected electron in circuit A. So we know that energy, the total energy is equal to the work function plus the kinetic energy. This is usually EK max. So it's basically the maximum kinetic energy. Let me just add max here. So this is a 5-mark question. So you know that you're gonna have to go through some extra steps in order to get this. So firstly, we calculate our work function for the calcium metal plate. So for the work function, that's H, that's Planck's constant and threshold frequency, where our threshold frequency is given as 5.07 times 10 to the exponent 14. So 6.63 times 10 to the exponent negative 34 multiplied by our threshold frequency. It's 5.07 times 10 to the exponent 14. What answer did you get for that?
3.36 times 10 to the power of minus 19.
3.36. So from this, we know our work function, and in the previous question we found the energy that the electron, that the light gives to an electron. So this is our E here. You understand that part?
Yes, sir.
So basically we just have to make EK max the subject of the formula. So we're gonna get EK max that's gonna be equal to the total energy from the light minus the work function. So our total energy, that's gonna be 3.62 minus 3.36. All of this is gonna be in brackets times 10 to the exponent negative 19. So what answer did you get?
I got 2.6 times 10 to the power of minus 20.
Okay, so that's gonna be our EK. So that's gonna be in joules. So that's your maximum kinetic energy. So I think it's a simple enough concept for it. So you understand it, right?
Yes, sir, I got it.
Okay. So now they're asking, how will the maximum kinetic energy of the ejected electron calculated in 11.4 change if the intensity of the light is increased? Will it increase, decrease, or remain the same? So in this question, Yvonne, have you guys been introduced to to which properties does the intensity increase? Does the intensity of the light affect?
No, sir, we haven't gotten there.
Usually the intensity is going to affect the amount of electrons that are ejected, because the intensity of the light is not going to cause any change in the wavelength. It's not going to cause a change in the frequency. It's just that now, instead of, let's say, let me just draw something here. Let's say this metal, right? So instead of one line now, it's going to be like 2 or 3. So it's basically, you're just shining more light onto it, but the frequency of the light and the wavelength are going to remain the same. So since the frequency and the wavelength are going to remain the same, the amount of energy is still going to be the same. And if the energy is going to stay the same, that means the kinetic energy will not be affected. Basically, you're just increasing the amount of light. You don't increase the wavelength or anything else. You understand that part?
Yes, sir. So what does it change again? What
It only
does it change?
changes the amount of electrons that get ejected.
Okay.
Yeah, so when it comes to kinetic energy, it's gonna remain the same. Only the number of electrons ejected changes. So this was an interesting question, to be honest. So from all of this, is there something that you find a bit more difficult, or maybe I can explain in better words to you?
I think I'm fine with everything we did so far.
Okay, so you guys are gonna be writing your term 3 tests soon, right?
Yes, sir.
So if I remember well, in physics, that's gonna be electric circuits, generators and motors, and the photoelectric effect.
Yes, sir.
And in chemistry, that's chemical equilibrium and KC. redox half reactions, which is electrochemistry. And I don't remember the third chapter.
So I can send you a picture of it now.
Yeah, you can just send it to me on WhatsApp. So since you haven't attended like most of my classes, we did the photoelectric effect. Can we go back to generators and motors?
Yes, sir.
Okay, I just got your photo. Newton's laws of motion. That's grade 11. Galvanic cell, electrolytic cells, acids and bases. Oh, so you're also gonna do acids and bases.
Yes, sir. But
So
we haven't covered acids and bases, galvanic cell, and electrolytic cell.
when it comes to galvanic acids and bases, you're mostly gonna learn about congruent acid base pairs, and you're gonna learn about which one are those? Like there's these substances that act both as an acid and a base, for example, water. But yeah,
Sir.
yeah, those two. Then in galvanic cells, they're gonna give you half reactions, redox reactions, where one element is gonna be reduced and the other element is gonna be oxidized. Then it's up to you to determine which is reduced and which is oxidized. Then you're gonna know which is gonna be a cathode and which is gonna be an anode. So I don't think we should dwell too much onto that. So when it comes to let's just go back to generators and motors. When it comes to generators and motors, have you guys learned everything about them? Or do you still need help with some few concepts?
So I think we went over everything on it. I'll just go over it again in my pastime so I can get it
Okay,
fully.
so for generators and motors, I'm just gonna give you like a quick snippet of what you need to know. So basically, for generators and motors, you need to know the right-hand rule. You need to know the difference between an AC generator and a DC generator. You need to know the energy conversions that take place when a generator is in operation. Then you need to be able to identify the maximum voltage of an AC and DC generator, because most of the time they're going to give you like different graphs. As you can see, this is an AC generator graph, and a DC generator graph might be something like this. So you just need to know like the difference. And you need to know the root mean square voltage. But usually they're gonna give you guys all the equations that you're gonna need for generators and motors at the back. And I think another one, that's where you need to calculate the price of electricity. But calculating the price of electricity, it's very simple. I think so. Have you guys done all of that?
Yes, sir, except for the calculating the electric cost of electricity.
Okay.
But I think I did it last year though, so
Yeah, it's, to be honest, it's a very simple concept, because they're just gonna tell you that this particular appliance, let's say it uses 200 watts, and it's gonna get used for, let's say, 4 hours. It uses 200 watts. It's gonna get used for 4 hours. And they're gonna give you the price of electricity, let's say 50 rands for 1.5 watts hour, you know. So they're gonna, they just like calculate the price of electricity. So you just change this. You just take this. Let's say it uses 200 watts per hour, and it's used for 4 hours. So that means it's gonna use 800 watts in all of that in 4 hours. Since the price of electricity is 50, you're just gonna take this, multiply it by 50. It's 50 per watt. Yeah, okay. Since the price of electricity is 50 rands per watt, so you're just gonna take that, multiply this by 50, then you're just gonna get like 4,000 rands. So I think it's not that hard.
yes, sir, I got it.
So Timlin, so I'm sorry, maybe like I'm butchering your name. So today's section, you guys were supposed to write a test, but I sent it to Javon yesterday, so he got an opportunity to write it. He sent me the script. Is it fine if I send it to you after this session? Then you can write it and send it to me before tomorrow morning, because I have to compile your report cards tomorrow. Can you hear me? If you're not able to speak, you can just type it in the chat, so I can know whether I can send you the test after this session. Then you'll give me your answers tomorrow morning, or how how you can write the test, because tomorrow I think Rizan said I must send him your report cards. I don't know. I'll just wait for your response, I guess. So so can we continue to paper 2?
Yes, sir.
So you only did KC. You only did chemical equilibrium, and I think I sent it to you in the test, right? There was a chemical equilibrium question.
Yes, sir.
Okay. So this is also a chemical equilibrium question. Or first, let's just do the one in the test so you can have an idea of how it was supposed to be done, because this question, they come in different ways. Like they can give you this, they can give you this graph, and they just change the figures here and there. They ask you what's gonna happen if this concentration changes, if that changes, using Le-Chatelier's principle. So are you aware of Le-Chatelier's principle and how it works?
So I don't remember it fully.
So let me just check if there's a question based on it. Nah, there's no question here. Let's go here. I think there was a question based on Le-Chatelier's principle here. Yeah. So it's this one. So basically, Le-Chatelier's principle describes the change in the reaction, and what happens in terms of the products and the reactants. So let's say we have our equation, we have our chemical equation here. So these are our reactants, and these are our products. So you need to know what affects the chemical equilibrium and what affects the chemical equilibrium constant. So our chemical equilibrium, it's just an equilibrium where this shows that a reaction is at equilibrium. So that's just our chemical equilibrium. Our chemical equilibrium is basically a state in which the forward reaction and the reverse reaction are happening at the same rate. And our chemical equilibrium constant, that's Kc. So Kc is the concentration of the products at equilibrium. This is to the exponent of the coefficient of the products. Coefficients, that's basically, here there's a 1 and here there's a 1, but here there's a 2. So these are our coefficients. This is divided by the concentration of the reactants at equilibrium to the exponent of the coefficient. So one thing you need to know about Kc is that it only applies to, I think it's mostly gases and solutions in aqueous state. Solids are not involved in the chemical equilibrium, as well as liquids, if I remember well. So if you have a reaction, let's say NaCl plus water H2O. Then our NaCl is going to give us Na, I think it's plus, which is in an aqueous phase. Usually salt is in a solid phase and water is in a liquid phase. And this is going to give you plus Cl, which is also in an aqueous phase because now it's inside the water. I'm sorry, but this Q is terrible. Then plus H2O liquid. So when it comes to our chemical equilibrium, since water is a liquid and NaCl is a solid, the reactants, there's nothing in the reactants, so it's just gonna be 1. Because this is a solid and this is a liquid. But in the products, this is in an aqueous state and this is in an aqueous state. So you can actually put the concentration of the sodium ions and the chloride and the chlorine ions, chloride ions up here. But since this is a liquid and this is a solid, you can't put them down here. So I think that's just one of the rules of the chemical equilibrium. So I think you understand so far.
So I understand.
Okay, so Ejected's principle, it's basically there to describe what happens when a factor that affects the chemical equilibrium comes into play. So the chemical equilibrium is gonna be affected by volume, pressure, and temperature. So according to Ejected's principle, let's just assume that the forward reaction, where's that? Let's just assume that our forward reaction is exothermic. So firstly, I'm gonna show you how the temperature is gonna affect the chemical equilibrium according to Ejected's principle. Then we're gonna go to the volume. Oh, and also concentration also affects the chemical equilibrium. So we're gonna look at our temperature, our concentration, volume, and pressure. So let's say our temperature increases and our forward is endothermic. Since our temperature is gonna go up and the forward reaction is endothermic, that means you're adding, as the temperature goes up, you're adding heat, you're adding energy, So the forward reaction is going to be favored because in an endothermic reaction, energy is received from the environment and into the reaction for it to occur. So once the temperature goes up, it's going to support the endothermic reaction. Do you understand that part?
Yes, sir.
And when it's going to go down, it's going to support the exothermic reaction. If the forward reaction is endothermic, automatically the reverse reaction is exothermic. So if the temperature goes down, the exothermic reaction is going to be favored since now you're taking heat out of the system. Then that means there's going to be less products and more reactants if the temperature goes down. And if the temperature goes up, there's going to be less reactants and more products. So that's how Ejected explained it. And then now we're gonna move forward to another thing, to another factor.
Yes, sir.
So we're gonna look at volume now. Volume, it doesn't directly affect the chemical equilibrium. It indirectly affects it because when you change the volume, you change the pressure, and that pressure is what affects the chemical equilibrium. So let's say we take our volume and we increase it. That means we're gonna decrease the pressure because volume, you know that PV is equal to nRT, right? Then in order to leave pressure alone, you're gonna divide by V. So in this case, we know that pressure is inversely proportional to the volume. You understand that?
Yes, sir.
So when the volume increases, the pressure is gonna decrease. And when it comes to pressure, that's where those coefficients come into play. But in this equation, pressure won't change anything because here the coefficient is 2, right? That means there's 2 moles of hydrogen iodide. But here also, you take 1, you add 1, it's still gonna give you 2. So a change in volume or pressure is not gonna cause any change. But let's say we have 3 PQ. This is just like a reaction that I'm gonna make up. So let's say it's gonna give us P3 plus 3Q. Okay. So in this particular reaction, when we're gonna increase the volume, we're gonna decrease the pressure. So the pressure, so the equilibrium, the chemical equilibrium is gonna support the side with less moles because here it's 3, but this side it's 4. So when pressure decreases, it supports the side with less moles. But when the pressure increases, it's gonna support the side with more moles. Do you understand that?
Yes, sir.
Yeah, so that's basically how you're gonna use Ejected's principle. It's usually like a 3-mark question. So Since we have a bit, we have like 3 minutes remaining. I don't know.
And so what about concentration?
Sorry about that. You see, in this case, we have our concentration as 1, right? Let's say now we're gonna increase the concentration of this, right? The reaction will no longer be in equilibrium until more of PQ is converted into P3 and 3Q. So once you increase the concentration of PQ, more products are gonna be formed. And when you increase the concentration of the products, more reactants are gonna be formed in order to rebalance the chemical equilibrium, because Kc never changes unless if the temperature changes. So your equilibrium constant doesn't change until the temperature is changed. So if you increase the concentration of this has to be converted into this. You increase the concentration of reactants are going to be converted into products, more products. That means you have more products and less reactants. You increase the concentration of the products are going to be converted into the reactants, because it has to stay at equilibrium and the value of Kc has to stay the same until the temperature is changed. So do you understand that?
Got it.
Yeah, so the equilibrium constant is only affected by the temperature, but the chemical equilibrium, it's affected by the concentration, the pressure, the volume, and the temperature. So I just hope that you don't